In this video, we'll see how to create a histogram using MATLAB's plotting tools. So I'll call this subsection histograms. Sure, why not? And in order to create a histogram, we need some data. So let's create an X array, and I'm just going to put in a bunch of numbers. Maybe they could be exam scores. I don't know. I'm going to pick a bunch of two-digit numbers, 22, 78. The more you have here, the more interesting your graph will be, so I'm going to take a few minutes to put in a couple. 93, dot, dot, dot. Remember, that's how we continue on to the next line. Let's say 88, 86, 69, 55, 72. That should do it. And then I'm going to use the command hist for histogram. It's just that easy. Feed in your data and say, make me a histogram. By default, let's go ahead and run this section. By default, you get 10 what are called bins or classes. So the data is divided into 10 groups based on the lowest and the highest numbers, and then you get a frequency count. How many items were in this bin from 20 to 30? How many were from 30 to 40? Oh, my bins don't go from 20 to 30 and 30 to 40. My smallest number was 22, so my bins by default in MATLAB will start at 22. And so they just take the range from 22 to whatever and split it into 10 equal size intervals, and then they count how many items are in this interval or this interval or this interval. And that's a histogram. Let's actually plot this. I'm going to close this and say, let's subplot just for practice. Subplot 2, 1, 1. So we're going to have a 2 by 1 plotting area, and then the first one we'll put a regular histogram. Let's title it while we're here. Every plot deserves a title. Let's call this final exam scores. Not your class, some other class, I'm sure. And then in the other subplot zone, so 2, 1, the M and the N stay the same, but now I'm shifting my focus to number 2, subplot 2, 1, 2. Let's set the number of bins to 25. I feel like this would be more interesting with more data, but time is short. 85, 97, can't type. 78 again, and 78 again. Okay, so now I've said this was the default where we had 10 bins, and here I'm setting the number of bins to be 25. And we'll get these side by side on the subplot. Well, not side by side. 2 rows and 1 column means they'll be stacked on top of each other. Let's run it and see. So here's the default with 10 bins, and wow, I made all those bins have the same number in them. That's so boring. Oh well. The second plot shows a little bit more detail because we have more bins. That means each one is smaller, which means we get more distinction between them. So we can do that. We could say, give me, I don't know, 80 bins. What's my smallest number? 22. So give me 78 bins. 78, 79, almost one for each. And now when I run it, I've lost my window, it's behind. We only get 1 of each. So less interesting actually, but at least they're clustered over here near the 80s and 90s, so we can see that they're fairly good scores. All right, some other things we can do with histograms while we're here. We could say how many are there in each bin. This outputs the number in each bin. Each bin. There we go. So sure, let's do that. Run section. Well, I've made it not very interesting. But you get 1 through 10. So this was for the regular old hist X. That's where we have 10 bins. So I get 10 different numbers. A count for each bin. That's what that is. All right. Let's say N is another interesting thing to do. We can say hist C, histogram count function. This allows you to set the bin sizes in case you want them to be different. So maybe I don't care whether you get 20 points or 30 points on the final exam. I just care that you got less than a passing grade. So let's create a bin that goes from 0 to 60 all of those will be classified as F. So what's the difference? 0 to 60, and then 70 is the next number I care about, maybe 80, 90, and 100. Oops. There we go. So if I use this, it will group everything from 0 to 60 together. It will group everything from 60 to 70 together, and so on and so on. So this Hist-C allows you to define bin sizes, and maybe they could be irregular ones. Oh, but because I have a 100, I actually need this to go to a 100.1. If it's exactly 100, then the score that's 100 won't get counted in there. So let's run this and see what we get for n. Here are my counts. There were 3 in this 0 to 60 range. There was 1 in the 60 to 70, 5 in the 80 to 90, and so on down the line. And I've got a 0 for the ones beyond that, the 100.1 and above. So Hist-C allows you to define your bin sizes if you want to. So that's histograms. All for now. See you next time.